this video, we will look at statistics, particularly statistical inference. And here I have the vocabulary questions from your notes. Feel free to pause the video so that you can see these. Statistical inference is the process of drawing conclusions about an underlying population based on a sample or subset of the data. The likelihood of an outcome occurring is called a probability. A set of measurements or observations in a statistical study is said to be statistically significant if it is unlikely to have occurred by chance. If the likelihood of an outcome as extreme as the one observed is 1 in 20 or 5% or less, the difference is statistically significant at the 0.05 level. If the likelihood of an outcome as extreme as the one observed is 1 in 100 or 1% or less, the difference is statistically significant at the 0.01 level. An outcome is a possible result of an experiment or trial. The outcomes or combined collections of outcomes of an experiment is called an event. Suppose you draw a single sample size N from a large population and measure its sample proportion. The margin of error for 95% confidence is approximately 1 divided by the square root of N. Hypothesis testing is a systematic procedure for deciding whether the results of a research study support a particular theory which applies to a population. The null hypothesis is the starting assumption for a hypothesis test. The alternative hypothesis is a claim that the population parameter has a value different from that claimed by the null hypothesis. When we have evidence in support of the alternative hypothesis, we reject the null hypothesis. When we lack sufficient evidence to support the alternative hypothesis, we do not reject or fail to reject the null hypothesis. Working with equal sample sizes, researchers compared 3 new cold remedies to a placebo. Which remedy is most likely to be most effective? And the answer here is the one that has the lowest level of significance. So 0.01 is the most significant because the likelihood of an outcome as extreme as this one is a 1 in 100 chance. And that's not very likely compared to a 1 in 20 chance, which is what the 5 level means. If we have 10 different experiments, 9 of the 10 are not statistically significant, but one of them is. What can we say that is a fair report of the results? The treatment works effectively about 10% of the time. We can have 95% confidence that the treatment works for at least some people. There is no evidence that the treatment works. This is a multiple choice. Which of these is the best answer? It turns out that because 9 of the 10, that's 90%, didn't work, that means that 10% did, which is more than 5%. There is no evidence that the treatment works. We can't even say it works 10% of the time. We can't even say it works for some people, because that could have just happened by chance, because it's that 10% is larger than this 5%. Find the margin of error and the 95% confidence interval for the following studies. Margin of error, I'm going to denote as MOE, was given in that formula on the previous vocabulary list. 1 over the square root of N, where N represents the sample size. In this case, the sample size is 2010, so our margin of error is 1 over the square root of 2010. When you put that into your calculator, you get 0.0223, or about 2.2% margin of error. The second part of the question says to find the 95% confidence interval, which we did in a previous lesson. All you do there is you take your percentage and you add and subtract your margin of error. So 83 minus 2.2 is equal to 80.8%, and 83 plus 2.2 is equal to 85.2%. So your confidence interval ranges from 80.8 to 85.2%. Letter B, we're going to do the same thing. The margin of error is found by doing 1 divided by square root of n, or in this case, 1 divided by the square root of 1035. When you put that into the calculator, you get 0.031, or about 3.1%. The confidence interval is 37% plus or minus the 3.1%. So 37 minus 3.1 is equal to your 33.9, and 37 plus 3.1 is equal to your 40.1, and there's your confidence interval. Question number 2, we have a survey with a margin of error of 4%. We want to reduce the margin of error to 2%. Should we repeat the survey with half as many people, twice as many people, or 4 times as many people? Well, if we want a smaller margin of error, then we need more people. So it definitely can't be letter A. But then whether or not it's B or C, we need to do a little bit of algebra. We have 0.04, and that's equal to 1 over the square root of n. That's our formula for the margin of error. When we do the algebra, we multiply both sides by square root of n, and then we're going to divide both sides by 0.04. Then we take the square of both sides to undo that square root. So n is equal to 1 over 0.04 squared, which ends up being 625. Well, what is it when we have a 0.02? So we're going to do the same thing. 0.02 equals 1 over the square root of n. I'll spare you the details, but it's exactly the same algebra. You get n equals 1 over 0.02 squared, which ends up being 2,500, which happens to be 2,500 is equal to 4 times 625. And so the answer is 4 times or quadruple. So if you want to half the margin of error, you must quadruple the sample size. Hypothesis testing, as mentioned on the first page, is a systematic procedure for deciding whether or not the results of a research study support a particular theory which applies to a population. So someone makes a claim and they say, you know, an example might be is, you know, does this vitamin C reduce the length of a cold? All right, so they do an experiment. In this case, its college president claims that the 6-year graduation rate at their 4-year college is higher than the national average of 60%. So the null hypothesis always has an equal sign. Always has an equal sign. If you notice, this is kind of like a little equal sign. So it's the proportion, the graduation rate is 60%. Or we might call that the proportion is 0.60. Okay. That's 2 different ways of writing the null hypothesis here. It has an equal sign. The alternative hypothesis is whatever is the claim. The president is claiming that it's higher than 60%. So we would say the rate is higher than 60%. or we would say the rate expressed as a proportion, oops, not an equal to. Alternative will have the greater than or the less than, or sometimes a not equal. And those are your two hypotheses. When you run the data and we actually collect the data, you end up getting a p-value, which is beyond the scope of this course, how to actually get that p-value. But once they get the p-value will either be less than your level of significance or greater than or equal to it. And as the researcher, I get to determine what my level of significance is, 0.05 or 0.01, 5% or 1%. But once I've decided that, my p-value, if it's less than that, we reject the null hypothesis, which means we're rejecting the fact that they're equal. Therefore, evidence supports the claim that the graduation rate is higher than 60%. That's a short way of saying it. If you reject the null hypothesis, as in if the data that you collect comes back with a p-value that is less than 0.05, evidence supports the claim that the graduation rate is whatever the alternative hypothesis said. In this case, greater than 60%. However, if we run all the data and do all the tests on it, and it comes back with a p-value that's greater than 0.05, we fail to reject the null. Therefore, there is no evidence to support the claim that the graduation rate is greater than 60%. We can't say that it's less than, we just don't have evidence to support the claim that it's greater than. Okay, next example. This one gets a little bit wordy. The claim is that the percentage of flights delayed more than 15 minutes at a Denver International Airport is greater than the national average. The claim is that the percentage is greater than 15%. Okay, so the null hypothesis, oftentimes denoted H sub 0, this is the null, is P, the percentage, equals 0.15. That means 15%. The percentage is 15%. The null always has an equal. Okay. The alternative hypothesis is often denoted with an H sub 1, and it is the P percent is in this case greater than 0.15. The alternative will never have the equal in it. It's always either greater than or less than or not equal. And things that could happen if we run the data, which in this class, we're not going to actually run the data, but if P is less than 0.05, we reject the null hypothesis, therefore support the claim that the percentage is greater than 15%. You reject the null, you support the claim. If the p-value was greater than or equal to the 0.5 level of significance, we fail to reject. We do not reject the null, and therefore evidence does not support the claim that the percentage is greater than 15%. Okay. And then the last information here is just some information for you. If you're reading a research paper and they give a p-value and it says p is less than 0.001, that means that it was very, very, very significant results. So if it says the p-value is less than 0.05, it's significant, but not quite as significant as 0.01 or 0.001. If a research paper provides a p-value of p equals 0.42, this is considered significant at the 0.05 level, but it's not at the 0.01 level. And so peer-reviewed or refereed or scholarly journals are written by experts and are also reviewed by other experts. And so they're considered to be scientifically valid. So when you're looking for valid research, look for peer-reviewed journals and articles. Thank you all.